You're asked to sketch the graph f of x and state the degree of the polynomial and end behavior. So degree I can actually look at right away. It's maybe easier for some people if you expand any exponents. So in this case, I have x minus 4 and squared. So I can see that the degree is actually going to be a third degree polynomial. Now the end behavior I'm actually going to graph here. So the x minus 4 tells me that if I were to plug in 4 into the equation, I would get 0. Same with the negative 5 from this piece. So that's where I get my zeros or my roots. And I know that because the x minus 4 is being squared, it's going to bounce off of this orange point right here. So it's a negative function, third degree, as I mentioned. So what that means is that I'm ending by pointing down. So a third degree should look like this here. So I come through here and I'm crossing through negative 5 because of this right here. If I were to actually find the y-intercept, I'd plug in 0 for x. I get negative 4 squared times 5. I'd get negative 16 times 5. And what you'd realize is that it's going to go way down below my actual graph here. So I'm just going to, again, this is not a perfect graph, but I'm just sketching. So at this point, when I go back to 4, I'm bouncing off of that point because it is x minus 4 squared. And if I were to zoom in on this, when it's squared, it should zoom in to look like a parabola. So it bounces off that point and goes down forever. So there's my sketch, my end behavior. So as x approaches negative infinity or decreases, y is going towards positive infinity because as we go to the left, the y value is going up. As x goes towards positive infinity, or as we go to the right, y is going towards negative infinity because as we go to the right, my graph is pointing down.